All right, so we're going to start to look at asymptotes, which are basically like, we can call them limit lines, basically, when we're graphing these functions. So a rational function in simplest form has vertical asymptote at 0 of the denominator, and horizontal asymptote. A rational function can have at most one horizontal asymptote. To find the horizontal asymptote, if any, we compare the degree of the numerator with the degree of the denominator. So we have two different options here. We can have a limit on our vertical kind of restrictions of where the graph can go, and also horizontal. So again, just to kind of go back, because I did that really fast. So the vertical is the 0 of the denominator. So we look at the denominator of the fraction that we're given in our function, and we say, what is the 0 of that? And that is our limit. We can't have 0 in the denominator, so it has to be greater than 0. Or just not 0, honestly. But for the horizontal limit here, we have three different options. So if n is greater than m, and we're looking at the degrees of the denominator, and n is the, this is not the greatest, kind of left off a piece here. So these m and n are referring to the degree of the numerator and the denominator. It should have actually set it up here, but I realized I left it off. So if the degree of the top is greater than the degree of the bottom, then the horizontal asymptote is y equals 0. If they're equal to each other, then the asymptote is given by the leading coefficient of the numerator divided by the leading coefficient of the denominator. So we actually have a fraction. Or if the degree of the top is greater than the degree of the bottom, then there is no horizontal asymptote. So we have three options there. So let's go ahead and apply this and see if we can see it visually a little better. So we have, and we're only graphing the asymptote, not the actual function on this one. So it just says graph all vertical and horizontal asymptotes of the rational function. So f of x equals 3 divided by 2x plus 9. So vertical asymptote, I'm going to look at the denominator, and I'm going to set it equal to 0. And I'm going to go ahead and solve. So I'm going to subtract 9 from both sides. I get 2x equals negative 9 because these 9's canceled. And I'm going to divide by 2. So 2 divided by 2 cancels. And negative 9 divided by 2, well, that's going to stay negative 9 over 2, which I could turn into a decimal for sure. It's negative 4.5. So you can see this dotted line showed up, and a lot of the time the asymptotes show up as a dotted line. It's showing you, this is kind of a limit for my graph when we do graph it. So this is kind of a stopping point here. And then we have our horizontal asymptote. So the degree of the numerator, n, is 0. So at the top, there is no variable with an exponent, right? So whenever I don't have a variable, my degree is 0. And then the degree of the denominator, which is m, is 1 because I do have a variable, but the exponent here is a 1. If I don't see a number, it's a 1. So 0 is less than 1, right? So the relationship here is, since it's less than 1, so the horizontal asymptote is at 0. Because that was one of the rules on that previous page that I had up there. So this is just kind of the beginnings of learning how to draw these kind of limit lines to help guide us when we're drawing our functions. So I hope that helped, and I will see you in the next video.